Hi everybody! Since I'm unable to be in class today, I thought I'd do a quick video on our notes so that you could follow along and still learn the new material. So you're going to need your Chapter 3 notes packet. You're also going to have to turn to the lesson 3.4, which is on angle bisectors. Compass and ruler are needed, but because of the limited supplies we have in class, we might need only one set per table. So, if you are ready, here we go. Here is our lesson 3.4 notes. Objectives today are being able to do the geometric constructions with the compass and straight edge. Also being able to construct special angles using our angle dividing skills that we're going to learn. So investigation number 1 is kind of a review. It says, what does the term bisect mean? And if we are going to bisect something, that means we are going to cut it in half. Alright, now on our picture of the baseball diamond here, it says sketch the bisector of the field, using the foul lines as the sides of the angle. So I'm going to take my ruler, I'm just going to use an arrow here, and I'm going to cut it right in half. So right in half would be right down the middle of this angle, starting at home plate, going right down the middle so that each half of the field is equal in size. Then it says, what locations could be located along the angle bisector? So knowing a little bit about baseball or softball or kickball even, we have 3 bases, first, second, and third. Second base should be along that angle bisector. And then wherever the pitcher is standing, the depth of the pitcher depends on the sport itself, but the pitching mound should be on the angle bisector as well. So we have both the pitching mound and second base. And if you've ever played any type of sport involving a diamond like this, the distance from first base to second base, let me just put in a little fake second base here. Here's our second base. The distance from first to second and second to third, those distances are equal. So you're going to be running the same amount, whether you're going to second or to third base. And then it says, using this information, complete the conjecture. So this is our key idea. These questions were just getting us there. It says, if we cut an angle in half, this is what we're going to have. If a point is on the bisector of the angle, then it is equidistant from the sides of the angle. Now we heard this before when we were doing the perpendicular bisector. The point on the perpendicular bisector was equidistant from the endpoints. So this is kind of the same idea. So I could mark in here that this distance would be the same as this distance here, and each half of my field is congruent. We can also see that down in this picture below, where I have an angle that has been bisected. I have a point on the angle bisector, and if I were to perpendicularly connect that to the sides, both of those distances would be the exact same. So I could also put hash marks in these, showing that the segments are equal as well. Alright, on to the next page. Alright, as I said before, last time we did the perpendicular bisector and also just perpendiculars. When we did that, we created a 90-degree angle. Since 90 degrees is half of 180, we actually bisected a 180-degree angle. But technically, we don't say that angles can be 180 degrees, so that's why I have it in little quotation marks here. It's not truly an angle, it's just a line, but we're going to go with cutting it in half is the same as bisecting a 180-degree angle. So I'm going to grab my compass, and what we're going to do is repeat the steps of doing that perpendicular. So we're going to take our compass and we're going to place it on the point that's given. So with my compass on the given point, what I want to do is create 2 points that are equidistant from that point. So I'm going to take my compass, open it to any size that I want, and I'm going to make a semicircle. If you want a full circle, that's fine too. But I just need it to hit this line twice. So I'm using my compass to make that semicircle, ensuring that it's hitting my line twice. Again, the size of my compass doesn't really matter. Next, I'm going to use those 2 intersection points as my new location for my compass. Now, because the point is on the line, it is very important that we open the compass slightly larger before we do our next marks. So I'm going to grab my compass and make it slightly larger than my original circle. Granted, you don't want it too big because you don't want it to go off the page. Just make it a little bit bigger than the original circle. Then I'm going to take my compass and I'm going to place it on one of those intersection points. From here, what we want to do is we want to create 2 arc marks below that cross. Those arc marks where they meet will be equidistant from both of these intersection points, and then we can connect that to the original point to make a 90-degree angle, or to bisect our 180-degree angle. So here I go, I'm making 1 arc coming off of this intersection point, and then I'm going to shift over to the other intersection point and make the other arc. Here goes my second arc. And where these cross could be outside of this first circle, they could be inside that first circle. It kind of all depends on how big you made your compass for each of those steps. Okay, so the screen probably looks weird because I realized that I had the wrong page here. So I just fixed that and I'm going to continue. So now we're going to take our ruler and we're going to connect that intersection point up through that original point that was there. This does create 2 right angles, so I could make the little 90-degree symbols here. And technically that is an angle bisector. So if we were going to write down the steps for this, what we did is we first made a semicircle. That touched both sides of our angles. And I put angle because it wasn't technically an angle, it was a line. Then we went to the intersection points and we made 2 intersecting arcs, but we did make our compass bigger. So make compass bigger, move to intersection points, and then make 2 new arcs below the line, aka the angle, and connect the original point, which could be called the vertex of our angle, with the intersection of the 2 arcs. Awesome. So you might need to pause to copy all that down, but make sure you get all the steps into your notes. All right, now this time we're actually going to do it on a real angle. So with our acute angle here, I'm going to follow the steps. Step 1 says, given the angle, place your compass at the vertex and make an arc that intersects both sides of the angle. The size of your compass doesn't matter at this point, so just place the sharp point at the vertex, the corner, and open your compass to make an arc that hits both sides, just like we did when it hit both sides of the line. From there, we want to emphasize those points of intersection here and here. And that's where my compass is going to go this next time around. But if I want to, I can also make the compass bigger here, like we did on the 180-degree angle. It's not necessary, but sometimes it does help to keep the lines from getting too messy, clunched all together. So I'm going to grab my compass and I'm going to move it to that first intersection point, and I'm going to make an arc mark. Keeping my compass the same now, move over to the other intersection point, make an arc mark. Okay, now I got a little excited and I forgot to read step 2. It says mark the intersection points as A and B. So if I call this one A and this one B, from A to B, from A to the vertex and from B to the vertex, it is the same distance. So they are equidistant. And then I already did step 3 where I placed my compass and made an arc. Did the same thing for step 4, placed my compass on B and made an arc. And now I'm going to use my straight edge to connect from the vertex all the way through the intersection point of those 2 arcs. This creates 2 equal halves of the angle. All right, we can repeat this now, going down to the obtuse angle, and it's going to be the exact same steps. So I place it on the vertex, get to choose my compass size, make an arc that hits both sides of the angle, and then from those 2 sides, or 2 intersection points, I'm going to place my compass again. Now remember, you can make your compass bigger at this point, but you don't have to. I'm going to make mine a little bit bigger, and I'll change the color so you can see it better. And I'm going to make an arc mark from that intersection point there, and another one from the right-hand side. And you can see my 2 arcs intersect each other. So I'm going to take my ruler, and I'm going to connect from the vertex through that intersection point. And again, I have cut the angle in half, creating 2 equal halves. All right, now in these next examples, we are going to be constructing different size angles using our perpendicular method and our angle bisector method together. So if we're asked to construct a 45-degree angle, we would need to first make a 90-degree angle and then cut it in half. So to create a 90-degree angle, I'm going to start with a line and a point. And I'm going to place my compass on that point, and I'm going to stretch it out so it goes across the line, making that arc that hits it twice. Then I'm going to place my compass on that intersection point. Again, I can make it a little bit bigger here if I wanted to. And I'm going to make an arc mark. You can make a full circle if you wanted, but all we need is the arc mark. Go over, and we're going to make another arc mark, or again, if you wanted the full circle, that's fine. And we're going to use our straight edge to connect both of those intersecting points, or the one intersection point with the original point. So this right here gets us to the 90-degree mark. From there, we need to cut it in half in order to get the 45-degree angle. So on this next one, I'm going to take my compass and I'm only going to focus on the right-hand side of my perpendicular lines here. So these green sections. All right, grabbing my compass, I'm going to place it on the corner of that 90-degree angle. The size of my compass will not matter at this point. Make it a purple color here, and I'm going to make an arc that hits those green rays on both sides. So I've got one here and here, and then I'm going to move my compass to those points. I'm going to make an arc mark in between them, move it over to the other one, arc mark in between, and where those 2 arcs crisscross, I'm going to use that point to connect back to my vertex. This has cut the 90-degree angle in half. So technically, this piece over here is 45 degrees. Let's make that black so you can see it better. So I have a 45, another little 45 piece, and a 90 piece. All right, example 2 is asking for a 135-degree angle. So we kind of already did that on the last example. If I include the 90 and the 45 piece, it makes 135. So just practice doing that one more time. And then over here on the triangle, just try cutting the 3 angles in half using the bisector method. It's the same exact method, it just happens to be a triangle. So you have 2 acute angles and 1 obtuse angle, and you want to cut each of them in half. So technically this is going to be like your homework today, a little practice, and then on Tuesday we will look at it together.